Okay, so you should have gotten a reply from me about your exams, and I also sent out a video about the answers, so I wasn't going to spend any class time on it. I figured out I can save time just by sending you a video of it, so that way I won't have to discuss it during class time. All right, so a lot of people, you didn't get the final results, but I saw your work, and your work was consistent. Maybe you just put something in the calculator wrong. I could do that also. I messed up several times. Okay, so sometimes you could have, in fact, some of you had every single problem wrong, but you still passed because you showed me all your work, and I still was able to pass you because I saw enough of what was going on. Okay, maybe I should have told you this ahead of time, but one of the worst things you should not do on a test is to leave an answer blank. You should never leave a blank. If you leave a blank, what do? I have to give you a 0, right? Put something down, put down what you do know. I can maybe give you partial credit. Hey, if you only get 5 out of 10, that's better than 0 out of 10, right? So show me what you do know. Don't have the attitude, please don't have the attitude, oh, he's going to think I'm dumb if I write something. No, don't do that. Okay, I'm not going to think that way. I'm going to give you as many points as I think you deserve, and then go from there. Okay. Some people got pretty high score, and you only got maybe 2 or 3 fully correct. So yeah, the strategy is show me all your work, do as much as you can, go from there. Okay, again, the grading scale is 90, 80, 70, 60. So 90% an A, 80 is a B, 70 is a C, 60 is a D, less than 60 is failing. And remember, you get to drop 1 exam. Okay. Now, we're not going to have another exam for quite a while. Chapter 9 happens to be our biggest chapter, as you can see. So if we do our usual 1 section a day, it's going to be quite a while until the next exam. Okay. And the last exam is only 4 sections, so that'll come pretty rapidly. Okay, so I'll be starting 9.1. Now, just to give you a heads up, the rest of this course is calculus. We're doing an introduction to calculus. Okay, don't get overly scared, but I'll give you the calculus you need in our situation. I mean, of course, it's got math analysis for business, so we'll only do the part of the calculus that involves business applications. I mean, we are doing some calculus. Now, you're not going to know everything there is about calculus. You can formally take a calculus class. There's a Math 110 series, Math 110 A, B, and C. I happen to be teaching Math 110B also. It's calculus 1, 2, or 3. Those are 5 units. All right, and you can also take short calculus, Math 100 A and B. Those are only 3 units. So we have a 3-unit class, and not even all of this calculus. So you're just really getting the bare minimum, the bare beginnings of calculus, just to let you know. But everything we're doing from here on out is a little taste of calculus. But when we finish with everything here and everything here and everything here, you're not going to know everything there is about calculus. You're just going to get a small piece, and normally from a business perspective, so to speak. Okay, so 9.1 today. So according to our usual protocol, Thursday, I'll give you a quiz at the end that you can take home. It will be on today's material, 9.1. Okay, so look for several quizzes. And so it looks like we're not going to have our test until, what, October 27th? So we'll have a lot of quizzes, up until then. Okay. All right, so here we go. Now, calculus, if you've never seen it before, it can be considered kind of weird. There's a lot of difference in what happens. And so, Chapter 9, the title is something called derivatives. That's the main concept in calculus, something called the derivative. Now, yes, there is an English word called derivative, but the calculus derivative is something different. Okay? And yes, I realize your book may be different than mine, so just kind of be ready for that possibility that we may have some difference in what's going on. Okay, we're going to start off with something called limits in 9.1 on my page 535. Something called limits. Okay, so I could show you some terminology on page 536. All right, so if you've never seen this before, this really looks like a foreign language. Okay, it looks like LIM. LIM is short for limit. Okay, there's an X, there's an arrow, and then a C. Okay, we read this as limit as X approaches C. Okay, X arrow C. x approaches c of f of x equals L. Okay? Now, in case you can't see that, I'm going to write the same thing on paper here. Okay, so it looks like this. Okay? So lim stands for limit. The arrow says approaches. So x approaches c. So the way we read it is the limit as x approaches c. Then the rest I think you know how to read f of x equals L. So what does this mean? Okay, we're saying when x gets close to c, when x gets close to c, and that's a key point. We don't actually reach c. We are close to c. Then f of x or y is close to L. Or we're going to allow it to be equal to L or equal to L. So it's a strange new mathematics. It's a mathematics of closeness. We're close to a number. Okay? They're going to put a number here like 2 or -8 or whatever. Okay? Technically speaking, we're not plugging that number in. We're plugging in numbers that are very, very close to that given number. Okay? I know a lot of this is just nebulous right now. It doesn't make a whole lot of sense. But we'll see. We'll get to that concept. Okay, so limit as x approaches c, there's an arrow there of f of x equals L. Okay. This is on my page 546. In your book, it might be a slightly different page, but I'm pretty sure this thing is there somewhere. Okay. Now, on 537, you have something called one-sided limits. Okay. This is a limit. This is also a two-sided limit. So I'll put here two-sided. This is sometimes called a two-sided limit. Okay? It means coming from the left or from the right. Okay? Now we can have a one-sided limit. Okay? I'm not sure if you can read it, but I'll write it. Okay? Limit as x approaches c, they put either a plus or a minus sign here. Okay? There's a tiny little plus there. That's the limit from the right. There's a tiny little minus sign there. I'll write it for you in case you can't see it. Okay? That means limit from the left. Okay? Otherwise, you write it the exact same way. Okay? So again, this is on my page 537. I'll write it for you. They put a plus here. Okay? That doesn't necessarily mean a positive number. It might be positive, but it doesn't have to mean. It means you're coming from the right. Coming only from the right side, only coming this way. Okay? If there's a minus sign there, limit x approaches c, and they put a minus sign of f of x equals L. Everything else is the same. So everything here is the same as this and this, except they might give you a plus or they might give you a minus. That means you're coming only from the left. The language is the same also. So we say the limit as x approaches c, the x arrow c, the plus means coming only from the right side, only coming this way. The minus sign means you're only coming from the left. So these are sometimes called one-sided limits. One-sided limits. Okay. Yeah, you might say, I still don't know what you're talking about. I know, I get it. This is all kind of weird right now. So if they don't put a plus or minus here, it's considered two-sided. That means you're coming from both sides, both the left and the right side. If they put a plus there, it means you're only coming from the right side. It doesn't necessarily mean it's positive. It might be, it might not. The minus sign means you're coming only from the left. It doesn't necessarily mean negative. Okay. And an abbreviation I want you to get used to. DNE. DNE stands for does not exist. Does not exist. So sometimes the answer is going to be does not exist, or our abbreviation is DNE. Something does not exist. Okay. All right. So then new weird stuff. Limit x approaches c of f of x equals L. That means when x gets really, really, really close to c, or x approaches c, when x gets close to c, f of x or y is close to L, or it might actually equal L. This is called a two-sided limit. If there's no symbol here, it means two sides. If there's a symbol here, like a plus or minus, if there's a plus, the limit as x approaches c from the right. You're only coming from this side. Okay? If there's a minus sign, you're only coming this side. Those are called one-sided limits. And DNE is our abbreviation for does not exist. Okay, so I'm going to show you some examples from the text now, because right now your head might be spinning and say, I have absolutely no idea what you're talking about, so I better show you stuff from the book. And again, I apologize, my book may not be the same as your book, so I'm going to use the examples from my book. Maybe they're a little bit off, or maybe it's not in your book at all. Sorry, but you're still learning the material, hopefully. Okay, yeah, somebody had a question or comment?
I have a question on the writing. So on the one-sided limits, the first one is x arrow c, and then what is on the top of this?
That's a plus. Okay, that's a plus symbol. Maybe I put the arrow too close. X arrow c plus, X arrow c minus.
Okay.
Yeah, and just X arrow c. So the arrow means approaches. So X approaches c. So lim is short for limit. X approaches c. X approaches c from the right if they give me a plus symbol. X approaches c from the left. All right. Okay, so now I'm going to go straight to, so we have 1 to 28. So I'll try to do as many evens as possible. And here we go. Okay, 9.1. So I might need to ask somebody out there for help. Okay, it's on my page 545. Maybe I'll just ask somebody out there. Is it your page 545 also, or is it off? Can anybody tell me, please? That has the book?
Yes, that's the right one.
The right one? Okay. And I'll show it to you, but again, realizing it may not be the same. But for those of you who don't have the text and don't plan on getting it, again, so I'll show you pictures here. And maybe you can tell me if that's the same. Whoops, I have to go up a little bit. Okay, so the video is recording, so you can get it off that.
Yeah, the picture is not the same. The
Picture's not
graph?
the same.
Yeah.
Okay. Well, you're still learning stuff, hopefully. Okay, then on page 546. Again, those of you with the text, you can tell me, does this look different or similar? They should definitely be similar.
A little different, but more on the similar side.
More on the similar side, okay.
Mm.
All right, and so now you can see up to maybe 13-ish. I'll go scroll down a little bit more. And some more. Whoops. Bottom there. Okay. These are those of you that don't have the book and don't plan to get it. Okay, so it looks like as I do the problems, we're going to have some variance from what I have and what you have, but you're still learning this stuff, and hopefully you're getting similar stuff. Okay, so I was going to do the evens. Does this look like your number 2 or no? Anybody out there?
It looks
Mine
like
is,
number 1.
That's your number
Yes.
1.
Mhm.
yeah.
Okay. And this and this. Okay, so it's somewhat similar, I guess. So sorry about that. Something I could have done about it, but anyway.
Your number 1 is my number 2. Your
Okay.
number 2 is my number 1.
They switch these two?
Yes.
Okay, then maybe I have to do 1 because it's your 2. That means you shouldn't have the answer in the back. I don't know why they do that. I mean, what's the advantage of doing that? I wonder if they change additions just to throw us off. And how about 3 and 4? Are they reversed also, I'm guessing?
They're switched.
Yes. Yeah.
And 5 and
the
6 are
reverse
switched?
too.
The same. They're switched.
Switch. No, they reverse.
So my 1, 3, and 5 are your 2, 4, 6. Is that correct?
Yes, I guess, yes.
Okay, so I'll do 1, 3, 5. That's your 2, 4, 6. Kind of dumb, but anyway. Okay, it says limit as x approaches c. If you can't see it, the limit as x approaches c. They give you the c value, and then they want f of c also. Okay, so for number 1, c is 4. So here's 4. We're getting really, really, really close to 4 on both the left and the right. Okay? So if I get really close, the y values are close to -8. So the answer to part A is -8. But then f of c. Now, f of c means you're not a little bit to the left or a little bit to the right. You're exactly at that number. So f of 4, right smack dab at 4, what's the y value? -8. Okay, so this first example is kind of trivial. Okay, so when we get real close to 4 on both the left and the right, the y values are down at -8. And yes, f of 4 is also -8. Okay, so they happen to match. But that's not going to happen for 3 or 5, which are your 4. This is your number 4 and your 6. Is that right? I'm guessing?
Yes.
Yeah. Okay. Now, for number 3, they have a hole right here. I'm not sure if you can see it. At 20, comma 10, there's a hole. Can you see the hole? Or if you have the book, there's a hole there.
There's a hole.
There's a hole. All right. So when we approach 20 from both sides, okay, so I get real close to 20 on both the left and also the right, the y values are close to 10. So the answer to part A is 10. However, f of c means what's the function value right at 20. So right at 20, there's an open circle, which means there's nothing there. Okay, so the answer to part B is does not exist, or D and E. You can just write D and E, but does not exist. Okay, so one more time. When I do this limit stuff, part A, you're real close to 20, like 19.9 or 20.1. The y values are near 10. So the answer to part A is 10, but part B does not exist. Right smack dab at 20, not a little bit to the left, not a little bit to the right, right at 20, y values doesn't exist. So that's a D and E.
Professor.
Okay.
Professor.
Yes.
So are you saying that the answer A is X and B is for the Y?
The answer for part A is 10, the number 10.
No,
When X,
no.
when X
On the
is
top?
close to 20, when X is very close to 20, Y is close to 10. That's what this symbolism means. This means you're right exactly at the C value, or 20. Right exactly at 20, there's an open circle. So F of 20 does not exist.
So the X is represent the X and the C is represent the Y.
No, the C is an X value. C is a particular X value.
But on the top, the answer, the question answer for B, the top.
The answer to B,
Uh-huh.
or my 3 or your 4, is D and E, does not exist.
I don't get it.
Okay? Right when C is 20, what's the Y value? There isn't any. There's an open circle. So it does not exist. Part A says you're not right at the C value of 20. You're real close. 19.99, 20.001. There are points there. Those Y values are close to 10. Okay? I'm going to do 5, which might reinforce this. Okay? Similar thing. So this is your 6, I believe. Okay, this one goes like this. It comes down, open circle, and it jumps down to here. Do you see this dot right here? And then it keeps going after that. That dot looks like it's about -6. Okay, so part A, limit as x approaches C, which is -8. So when I get real close to -8 on both the left and the right side, where are the y values? They're just about 0. So the answer to part A is 0. At least write it down. Write it down. You can look at it later, but I'm giving you the answers right now. Okay. The answer to part A is 0. The answer to B, though, F of C, F of -8, right at -8, not a little bit to the left, not a little bit to the right, right at -8, there is a function value. It's down here, which is -6. Okay, that's -4, that's -8, so halfway is -6. Okay, so that's the answer to this one.
Can you move the page down?
Okay, moving along. Okay, help me with this. Do 7, 8, 9, and 10 match, but they're switched again, I'm guessing, or is the 8 same for you guys, or what? Somebody tell me, please.
They're switched again.
It's switched again. So my 7 is your 8, my 9 is your 10.
Yes.
Yeah, okay, so I should do my 7, which is your 8, I'm guessing. Okay, now look at what's happening here. They have the limit as x equals to c from the left. Okay, you can't see it, there's a tiny little minus sign there. That means you're only coming from the left side. B, there's a plus there. Means you're only coming from the right side. C, there's no symbol, so it's two-sided. And then f of c is the usual. Okay. All right, so part A, there's a tiny little minus sign. It's hard to see. Limit as x approaches c, the c is -10. All right, so as x approaches -10, only coming from the left. If I'm only coming from this side, it looks like the y values are shooting up to infinity. All right, so the answer to A is infinity. So for infinity, you can just use the sideways 8 symbol. So the answer to A is infinity. B, limit as x approaches c coming only from the right side. So as I approach -10, only from the right, the y values are also shooting up toward infinity. So the answer to B is also infinity. Okay, C, there's no symbol, so it's two-sided. Okay. No symbol, it's two-sided. In order for there to be a two-sided limit, the limit from the left and the limit from the right have to be the same. If they're different, we're going to say it does not exist. Okay. In other words, the answer to C is, did you get the same thing for A and B? The answer is yes. The limit from the left was infinity. The limit from the right was also infinity. Therefore, the two-sided limit is going to be infinity. Right, so the answer to C is infinity also. How about D? F of C, F of -10. Okay, so right at -10, is there a dot anywhere on -10? No, there isn't. So the answer to D is does not exist. D and E. Okay, so quick summary: A is infinity, B is infinity, C is infinity, D does not exist, or D and E. Let me show you C, which shows you the left and right stuff again. So once again, we're coming from the left, coming from the right, two-sided, and the function value. Okay, so the function goes like that: open circle, close circle, and then continues on there. Okay, we're approaching -4.5, which looks like it's right there. All right, part A, we approach the C value, -4.5, only coming from the left. If I only come from the left side, the y values are very close to here. Where's here? 3. So the answer to part A is 3. B, if I only come from the right side, there's a tiny little plus there. So if I come toward -4.5 from the right side, the y values are down here. So where's here? -6. So the answer to B is -6. All right. Now, what about part C? It's two-sided. To have a two-sided limit, the answers to A and B have to be the same. Was the answers to A and B the same? No, they were not the same. On the left, we were up here, 3, correct? Answer to part B was down here. So what's my answer to C? D and E does not exist. Okay, we do not have a two-sided limit. because the limit coming from the left side and the limit coming from the right side were different. And then D, F of C, right at -4.5. Right at -4.5, is there a dot? Yes, there is, down here. So the answer to D is -6. So that's what we have there.
Can you repeat letter C again, please?
I'm sorry?
Could you repeat letter C again, please?
C does not exist for this one because that's a two-sided limit. There's no symbol after the C. So it's two-sided. In order to have two-sided, the answer to A and B have to be the same. They weren't, so it does not exist.
So the answer is D and E.
The answer to part C does not exist. D and E, correct. Okay. All right, so now
What was D for
give you
that?
a chart. Now I have to ask you whether we get matching here. Is this your number 12? Does this match?
Yes.
That does match. Good. That's what I have. Okay. Now, what is going on here? So since it matches, I'll tell you what I have for my notes. Here's a function. They're asking for the limit as x approaches -0.5. Okay. Now, -0.5 is the same thing as -0.5. Okay. What is -0.5 squared? -0.5 times -0.5 is +1/4. So 1/4 minus 1/4 is 0. I cannot plug in -0.5. I will get 0 in the denominator. And yet, I'm actually going to claim that the limit exists. Because by using this symbol here, I'm not saying what happens when x is exactly -0.5. I'm close to -0.5. A little bit to the left and a little bit to the right. Now, what's going on in this table here? Okay. They are giving me these numbers. The top three numbers, we're getting very close to -0.5, approaching from the left side. These numbers are a little bit smaller than -0.5. -0.51, -0.501, -0.5001. And then these numbers, if I go up, okay, I'm approaching -0.5 coming from the right. -0.49, -0.499, -0.4999. Okay? So even though you cannot plug in -0.5 to the original function, it's not allowed, I claim we can actually find this limit. This limit does exist. Okay. So what do? We plug into the function. Okay. Now, to save time, I'm just going to give you the results. You can punch this in your calculator on your own. Okay. Now, if you're actually going to type this all at once on your calculator, on this calculator or whatever calculator you have, you should put extra parentheses. Okay. So that means you would go parentheses 2 times -0.51 plus 1 parentheses divided by parentheses 1/4 minus parentheses -0.51 squared parentheses parentheses. Okay. That's how you would do all of these. Okay. Now I'm showing you what I got. This is not a calculator class. Maybe just jot this down, or if you don't have to jot it down, it's on the video. You can look at the video later. But I'm going to tell you, when you punch these in, this is what I came up with. So in other words, plug in -0.51 here and here. Plug in -0.501 here and here. -0.5001 here and here. And -0.49, -0.499, -0.4999 here and here. Punch it in your machine, grind it all out. Okay? And to save time, I'm showing you what the results are. Okay? So 1.9801, and there's more, ... Just like when we're doing the last chapter, I don't feel like putting all the digits. 1.99800, 1.9998000. And then coming this way, 2.02, 2.002, 2.0002. Okay, so if you look, if I'm coming this direction or this direction, what seems to be happening to the numbers? The numbers are getting really, really close to what number? Looks like 2. So I claim the limit does exist. The limit as x approaches negative 0.5 of f of x is equal to 2. Even though you cannot plug in negative 0.5, you will get a 0 in the denominator. Okay. So f of negative 0.5 doesn't exist. Okay. But this symbolism here means you're not really plugging in negative 0.5. You're plugging in numbers that are very close to negative 0.5. On the left side, like these. On the right side, like these. And then if you look at the progression coming this way or this way, say, oh yeah, the numbers are getting very close to 2. So we're going to say that the limit is equal to 2. Okay. So that's the idea behind these problems. So 11, 12, 13, and 14, okay, you just plug in from the table they give you and then estimate based on the numbers. Okay. I will say a quick word about 14. Does this look like your 14? Anybody?
Yes.
It's 2. Okay. So this is a piecewise defined function. So just to watch out for that. You use the top one if x is less than or equal to negative 2, but you use the bottom one if x is greater than negative 2. So from the table, which ones are smaller than negative 2? The top 3, right? These are a little bit smaller than negative 2. So just jot this down in your notes. For the top 3, you're going to plug into the top one, 4 minus x squared. Is that right? These numbers are a little bit smaller than negative 2. And then numbers greater than negative 2 are negative 1.99, negative 1.999. So maybe just jot down in your notes or listen to the video later. These last two, right? You're going to plug into which one? This one, x squared plus 2x. Right there. Okay, so just jot that down. For the top 3, they are less than or equal to negative 2. Plug into the top one. The bottom 2, they are greater than negative 2. Plug into this one. Okay. All right, now the problems at the end. Then yes, I know a lot of you have questions and you put some stuff in the chat. So I'll knock these out. I have time. What time is it? It's only about 6:20-ish. So I should be able to finish and then answer some of your questions. And that's it. Okay, use properties of limits to find it if they exist, which means sometimes they don't exist. Okay, so how do you do 15 through 28? And that would be it, I think. Yeah. Okay, so let me switch to here. And let me just randomly choose some stuff here. Is this your 16?
No,
It's
different
not.
number.
That's different.
Oh yeah, 16.
Oh,
The
that's
one
the-
that here. Yeah.
Is this your 16?
Yes.
Is this
yes.
your 18?
Yes.
Just like that?
Yes.
And maybe jump around to 24. Does that look like it?
Yes.
Okay, so I'm guessing these are all the same afterwards. So only the beginning part. I don't know why the books do that, but anyway. Okay, limit as x approaches negative 35 of 34 plus x. Okay, here's the way to do these. First simple rule, if you can plug in, do so. What do you mean by that? Limit x approaches negative 35, just simply plug in negative 35. Okay, so what happens when you plug in negative 35? You have 34 plus a negative 35, which is equal to negative 1. So the answer is negative 1. That's pretty easy, right? So if you can plug in, just do so. Even though that's not what this symbol means. Okay? This symbol really means if you plug a number that's very close to negative 35, the answer is going to be very close to negative 1. And I think intuitively you can see that, right? If I plugged in negative 35.00001, you don't really have to do it. You can tell the answer is going to be close to negative 1. Right? And likewise, if I plug in negative 34.99999, I'm not really going to do it, but you know the answer is going to be close to -1. Okay, so for these problems at the very end, of which the last one was what, 28 on the homework? Yeah, and I'm doing a whole bunch of evens for you. Yeah, so all these, if you can plug in, do so. Which seems to imply there are situations where you cannot do so. All right, so let's see. Okay, 16, 18. Limit x approaches -1 or 4x cubed minus 2x squared plus 2. And I think you're saying this one matches? Does this one match, folks?
Yes, yes.
Okay. Limit x approaches -1. Okay, if you can plug in, do so. So I'll just plug in. So put -1 here, -1 here. 4 times -1 cubed minus 2 times -1 squared plus 2. Should not be an issue. We can do that. Okay. -1 cubed, -1 times -1 times -1 is -1. Multiply that by 4, -4. But what is -1 squared? 1. And 1 times -2 is -2 plus 2. Okay. Well, it looks like these two just cancel out, right? That's 0. So the answer is -4. Okay, so if you can plug in, do so. Even though that's not really what this means, we said, right? This really means if I plug in not -1, but I'm plugging a number that is very, very close to -1, the answer is going to be very close to -4. We're not going to bother doing that, but I think you can see intuitively. Okay, so if I plug in -1, I get -4. So therefore, if I plug in -1.001, it should be close to -4. Or -0.9999, it should be close to -4. Right? So that's that. Okay, somebody mute yourself, please. I hear background music. Everybody, please mute yourselves. Thank you. Appreciate it. Okay, 20. I hope this matches. Limit x approaches -1/2 of 4x minus 2 over 4x squared plus 1. Okay, does this one match? I'm hoping it does. This one match? Okay, I don't hear anybody, so I'm assuming.
Yes, yes,
Does it match?
yes,
Okay.
Professor.
Matches? Okay, good. All right, so you have to admit these aren't that bad. Okay, if you can plug in, do so. So plug in -1/2 right here and right here. And you might say, when's there a situation where you're not going to be able to plug in? 22 and 24. So we'll worry about it when we get to it. Okay, so put -1/2 right here. 4 times -1/2 minus 2. Plug in -1/2 right there. 4 times -1/2 squared plus 1. All right, 4 times -1/2 is -2. -2 minus 2. Okay, what is -1/2 squared? And a quick reminder, you're supposed to square first before you multiply, right? If you have multiplication and an exponent, exponent has higher priority. So first, what is -1/2 squared? -1/2 times -1/2 is +1/4, is it not? So on top, I have -2 minus 2, -4. The bottom is 4 times 1/4. Well, 4 times 1/4 is 1. 1 plus 1 is 2. So -4 divided by 2, -2. Right, so the answer is -2. But again, that's not what this symbol means. Okay. So what does this really mean? It means if I plug in a number that is very, very close to -1/2, the answer will be very close to -2. So that's like -0.5. So if I plug in -0.5001 or -0.4999, I'm expecting something that's close to -2. All right, so for 16, 18, and 20, straightforward. If you can plug in, do so. Pretty easy. You should be happy if I give you something like this on a test or a quiz. Frankly, it's too easy. It's just Algebra 1 stuff. So more likely, I would give something a little bit more challenging, like 22, and 24. Okay, so let's look at 22. Limit as x approaches 3 of x squared minus 9 over x minus 3. Okay, so what's quote unquote wrong with plugging in this time? Say, well, you just plugged in over here, and you plugged in over here, and you plugged in over here. Why don't I just plug in? What's wrong with plugging in here is what happens when you put a 3 right here, right? If you plug in a 3, 3 minus 3 is 0. You are dividing by 0. That's a mathematical no-no. We cannot do that. And yet, I still claim we can find the limit, because this really means I'm not plugging in 3. I'm plugging a number that is very, very close to 3, like 2.9, 2.99, or 3.1, 3.01. Okay. If I plug in those kind of numbers, this is okay, right? That's going to exist. I'm just not allowed to plug in 3, but I am allowed to plug in numbers that are close to 3, right? So you say, what do I do? So we have to do some algebra trick. Okay? And let's look at the numerator, x squared minus 9. Say, aha, that's factorable, right? From algebra, what's x squared minus 9? How do you get x squared? X times x. How do you get 9? 3 and 3. One's a plus, one's a minus. So x squared minus 9 is x plus 3, x minus 3. Remember that? Sometimes that was called the difference of squares. Difference of 2 squares, to be specific. Difference of 2 squares, x plus 3, x minus 3. And then you can say, oh yeah, now I can cancel these out, right? Since these cancel out, I'm now taking limit as x approaches 3 of x plus 3, and now you can plug in, you see? Now there's no trouble with dividing by 0. So now you simply just do like all the others. So plug in 3, 3 plus 3 is 6. So the answer is 6. So the limit as x approaches 3 exists, even though right exactly at 3, smack dab at 3, you can tell f of 3 does not exist. The function value does not exist, d and e. But the limit exists because I'm not really plugging in 3. I'm plugging in stuff close to 3. 3.1, 3.01, 3.001, 2.9, 2.99, 2.999. When you plug those all in, we're not going to bother making a table. This is much easier. Okay, we'll say the y values are very close to 6. Okay, so that's the idea of what's going on here. Okay, do one more like that, which is 24. Maybe I have time for more, but we'll see. What time is it? It's almost 6:30. Okay, I want to be able to answer your questions also. But 24. Limit as x approaches 7, x squared minus 8x plus 7 over x squared minus 6x minus 7. Okay, let's see about plugging in 7. Okay, if I plug in 7, what is 7 squared? 7 squared is 49, right? 6 times 7, 42. 49 minus 42 is 7. 7 minus 7 is 0. So yes, once again, I'm dividing by 0. So maybe we should do some algebra. Okay, so same thing, try to factor. Well, 7 is easy. How do you get 7? 1 times 7, there's nothing else, right? So x, 1, 7. A minus and a plus combination from algebra, you might recall, are going to be 2 minuses, minus, minus. X minus 1, x minus 7. If you were to multiply this back out, you get this. Let's try it. X times x is x squared. That times that is negative 7x. That times that is negative 1x. Negative 7x minus 1x is negative 8x. And then negative 1 times negative 7 is a positive 7. Then in the denominator, x squared is x times x. 7 again is 1 and 7. But this minus sign, you might recall, means the signs are opposite. One's a plus and one's a minus. You want to end up with a negative 6, so that means the negative goes with a larger number. Negative here, plus here. And there's the trick again. These two cancel out. So I have limit as x approaches 7 of x minus 1 over x plus 1. Now you can plug in. Okay, so plug in 7 here, 7 here. 7 minus 1 over 7 plus 1, which is 6 over 8. So the answer is 3/4. So it looks like the answer is 3/4. Okay. Let's see, we had to go up to 28, about 6:30-ish. Okay, I think I can do the last two even ones for you. Don't mind. So let me sneak that in here. So the last time I taught the course, I didn't have time for it, but maybe we do now. Okay, 26, please, is limit as x approaches -6. Okay, so I'm doing it now. 2x squared minus 72.
By the way, it's ours 28.
This is your 28. Oh no. 3x squared plus 18x. Okay, this is your 28?
Yes.
Okay, well, I'll write it as 28. Maybe then I'll ask you for 26 later, and I'll just go by what you say. All right, well, the pattern of the way these are going are you're not going to be able to plug in. Okay, the first problems are direct plug-in. I'm pretty sure that's not the style behind these, so there must be some factorization going on. Okay, so let's just go straight to factoring. What's a common factor on the top? Looks like it's 2, right? So limit x approaches -6, 2 parentheses, x squared minus 36. And what's a common factor here? Let's see, I can take out a 3 and also an x. So 3x parentheses, x plus 6. And by the way, yes, that clinches that you can't directly substitute, right? If you plug in -6 right here, -6 plus 6 is 0. So 0 times all that is 0. So yes, you'll get a 0 on the bottom. Okay. But if you keep going, you can factor this as a difference of 2 squares, right? So limit x approaches -6 of 2 x plus 6 x minus 6. X squared minus 36 is x plus 6 x minus 6. And just copy the bottom stuff. Okay, so it looks like the name of the game for 24, 26, 28, and stuff like that is to factor and then cancel. All right, so it looks like I can cancel. What can we cancel? X plus 6. And that was the offending item, so to speak, right? That was the one that prevented me from plugging in -6. But now it's gone. And now that I cancel it out, I can just plug in. So limit x approaches -6, 2 times x minus 6 over 3x. That cancels, that cancels. Now I just plug in. So I plug in -6. 2 times -6 minus 6 over 3 times -6. So let's see, that's -12, right? So 2 times -12 over -18. 2 times -12 is -24. Negative divided by negative is positive. So let's see, take out a 6, is that right? So if I take out a 6, I have a positive 4/3. Final answer? So the final answer is 4/3. Okay, so once again, you could not plug in -6 back at the beginning because you get a 0 on the bottom, but you are actually plugging in numbers that are close to -6, -5.9, -6.1. The y value is going to be close to 4/3. That's what we're saying there. Okay, I'll do 26, and then that's it. And then I'll let you ask questions. We have time. Okay. So I'm assuming my 26 is different also, but it might be close by. Okay, so can somebody read your 26, or maybe it's close to the ones I got? Can anybody look at your 26, and does it match any of these guys here? Or it's completely different? This is my 28, but you already told me it can't be the same. No?
Different.
Completely different?
Yeah.
Okay, well, can somebody just read me your 26, if possible. Which should say
Limit.
then X arrow, right?
Yeah, X is arrow half.
Pi?
One, yeah, half. One
Half?
over, yeah, half.
Like that?
Yes.
Okay. And does it give me a fraction, I'm guessing?
Yes, fraction up is 8x squared minus 4x.
Like that?
Yes, over x minus 1/2.
Okay, like that?
Yes.
Okay, thank you. And you're right, I do not see that in my book. Okay. So it looks like the author just made a few changes, and I don't know why they do that. Doesn't make sense, but be that as it may. All right, so we cannot plug in a half, because 1/2 minus a half doesn't work. Okay, so let me factor and see what I can do. Okay, what can I factor out of here? 4x, right?
4x.
4x. Then what do I have left over?
X
2x
minus 1.
minus 1. Is that right? Let's double check. 4x times 2x is 8x squared. 4x times -1. Okay, it works. Okay, what do I do now? Okay, there's a little bit of an algebra trick. There is a relationship between these two that I'm pointing, x minus a half and 2x minus 1. They're actually pretty close. If I multiply this by a certain number, I get this. Can you tell me what that might be? If I multiply this one by 2, I get that. Okay. So I'm going to multiply numerator and denominator by 2. Like that. So what do you want to do that for? Because I noticed that if I multiply this and this, I get 2x minus 1. Take a look. What's x times 2? 2x. What's negative a half times 2? -1. And then I can cancel these out. The whole idea is to be able to get that cancellation in this particular case. Okay? Okay, so I have 4x times, I'm going to multiply these two. 4x times 2 is 8x, right? I'm going to choose to multiply this. I'm not going to touch that. The reason why I'm not touching it is because I want to cancel that. So 8x times 2x minus 1. And I forced the denominator to be 2x minus 1. Okay. See, what I did was I noticed I can get this to look like this if I just multiplied by 2. So I went ahead and multiplied by 2, and don't let that 2 touch this. I made the 2 touch this stuff here. Okay. And now it looks like I can cancel these out. And then I can plug in. So limit x approaches a half of 8x. All right, now I simply plug in 8 times a half. Half of 8 is 4. So final answer is 4. Okay. All right, so I've done almost all the evens. Okay, so that's as much as I was going to do there. Let me stop the share and check your chat questions. Okay, so Jonathan, thank you again, Jonathan. And this one is, okay, and that was pretty much that for this. Okay, so otherwise I'm done. It's not even 6:40 yet, but I don't mind. So does anybody want to ask me questions now? If not, we can just stop as far as I'm concerned. Now, so looking back at the schedule, so next time we're doing 9.2. I'll give you a quiz at the end. It'll be just on section 1 material. And same as usual, I mean, you don't really have to study if you don't want to. I'll put you in a breakout room. You can talk about it. And it isn't even due until the next class meeting, which is next Tuesday. All right, so I'll lecture on 9.2 a while, and then I'll stop and give you the quiz. And if you don't have time to finish the quiz, just save it for next time. Okay, so
Yes,
anybody
sir.
want to ask me stuff? Otherwise, we can end.
Yeah.
Yes,
I was,
Arturo?
yeah, for number 10, D, I didn't get how you got that one.
10D, all right. So let me go back. Okay, so let me go back and we're still recording. Share the screen.
Oh, but I wanted to go over
I
something.
believe 10D is my 9D. Is this the question? Does that look
Yeah.
like it?
Yes.
I'm assuming this is your 10. Okay, yeah, that's silly. Okay, part D, F of C. So if you're not a little bit to the left, you're not a little bit to the right, you're exactly at -4.5. So right at -4.5, which is right halfway between -6 and -3, there's a dot, closed dot right here, and that looks like -6. So the answer to D should be -6. Okay,
Thank you.
you're welcome. And I think, Wee, you had a question, please?
Yes, yes. Is your quiz gonna be making tables?
Is the quiz going to be making tables? I think that's going to take too long, so I probably won't have you make a table. So most likely, I'll have you do something that looks like this. And most likely, I'll have you do something like the limits at the end. So I won't have you do a table that takes too long. So I'll probably have you do something like this. And warning, I'm probably not going to let you do the easy one where you just plug in.
Mm,
That's too easy. So you're probably going to have to do some algebra,
okay.
you know, like the ones we did at the end for the quiz.
So your exercise number, all the problem are different from we have. So what happened then?
Yeah, so just do what you have. Okay,
Okay.
that's okay. I mean, you're learning the material regardless. So just do your problems. That's fine. If you have a question about it, you can bring it up. So, you know, office hours or send me an email. Anything like that
Right.
is certainly fine. Okay. So,
Okay.
you know, having a different version of the book is actually not that big a deal, actually. The main thing is you're learning the material. And so when you submit the homework, you know, I say, does it look like what I have? Yes, it does. You know, that's good enough for me as far as I'm concerned. Okay. And let's see, the chat seems to be clear. Okay, so Queen, can you re-explain one of the graph problems? Okay, which one was it, please? You can either say it or type it in the chat if you wish. We have time. Any of them? Okay, well.
Yeah, the graphs are just not clear. Not clear, I mean, to understand.
Uh-huh. Okay, so let me go back to screen sharing.
Yeah, me too. I not understand at all.
Okay, so why don't I do something that is different than what I had? Let's see. Is this your number one? I think you said you switched these, right? So this is your number one. Is that correct, people?
Correct.
Okay. All right. So how about I'll show you that one? Well, oh, okay. This one is actually too easy because there's no hole like this one or like this one. Okay, so C equals 6. Okay, so limit as x approaches C, that means limit as x approaches 6. Okay, when I get really, really close to 6, either from the left side or the right side. Okay, so coming both ways, the y values are up here, whereas here looks like it's also 6. So the answer to A is 6. Yeah, you guys might be tricking me into doing all the problems, but you know, I know it happens, you know. So I might end up doing them all, but it's okay. So that's answer is 6. But how about part 2? F of C. So right smack dab at 6. Is there a dot here? Yes, there is. It also happens to be 6. So the answer to both A and B of your number 1, my number 2, is 6. because when I get real close to 6, the y values are here. And exactly at 6, I also have 6. Okay. That doesn't happen with problem 4 and problem 6, which means you guys have tricked me into doing all of these. That's okay, I don't mind. Okay. I mean, the main thing is go back home and study it later. Okay, now this one, there's a circle here. There's an open circle, right? So I'm guessing this is your number 3. Okay, let me see if I can read. This is 15. This is negative 10. Open circle. Okay, so part A, the limit as x approaches c of f of x. The c is negative 10. Okay, so when I get real close to negative 10 on both the left and the right, bring the graph up here, there are points there. So where's here? Where's the y value? It's near 15. So the answer to part A is 15. Okay. So the limit means you're nearby negative 10. The y is near 15. But part B, exactly at negative 10. What's the function value? It does not exist. There's an open circle there, and there's no other dot anywhere else. So the answer to part B is DNE does not exist. Right exactly at negative 10, there's no y coordinate. My 6 or your 5, similar thought, it goes like this, and then there's an open circle, and then there's a dot there. Okay. So what does that mean? Two-sided limit does exist. Okay. If I approach negative 2, the c value. Okay, I get real close to negative 2 on both the left and the right sides. The y values are near 0. So the answer to A is 0. How about part B? F of C, right at negative 2. Not a little bit to the left, not a little bit to the right. Exactly at negative 2. Is there a dot? Yes, it is, but I have to jump way up here to 2. So the answer to part B is 2. Okay.
Professor,
Yes.
so why exactly is it 2 on B? Are you plugging, like, what are you plugging in there to find? I don't understand.
Yeah, I'm putting exactly negative 2. And we're not really plugging in, because plugging in means they give you a function that looks like, stuff like this. Because there's a graph, there's no real plug-in. But we're saying part B, f of negative 2. If I'm exactly at negative 2, what's the y value? Well, it's over here. It's 2. Okay. If you can kind of just block out of your mind anything near negative 2, if you can focus only at negative 2 right there, where is there a dot? Right up here, 2. But for the rest of the graph, okay, now I am near negative 2. That's part A, the limit. So if I'm a little bit to the left or a little bit to the right of negative 2, the y values are down at 0, near 0. Okay, so that's what's
So
happening.
am I supposed to always focus on the y value? Is that?
The answer to the limits are the y values, correct. Okay, it's a y value. Which, by the way, that's what f of x is. F of x means y. Y equals f of x. So we're saying when x gets something, near something, what happens to y? Y gets near whatever. Okay. Well, if I go like that, maybe you can see it better. But anyway. Okay. Let me check the chat again, or did we get caught up on chat? Oh, I think I'm caught up with the chat. All right. Anybody else want to ask stuff? Otherwise, we're done for the day. All right, folks. So next time, section 2, I'll give you a quiz on 6.1. But you don't really have to study. Just help each other out. I'll put you in your breakout groups, and it isn't due until next Tuesday. Okay. All right, that'll do it, folks. So everybody have a good night. And we'll
Thank
see next
you.
time. Okay. Bye,
Thank you.
everybody.
Bye-bye.
Thank you.
Bye.
Good night.
Thank you.
Thank you.
Thank you.
Thank you.